In this video, we'll learn about chemical properties of hydrogen. The first one is combustion. Hydrogen is combustible gas, but it's not a supporter of combustion. Thus, if a burning splinter is brought in a jar of hydrogen, it gets extinguished while the gas burns with a pop sound at the mouth of the jar with a pale blue flame. The reaction is highly exothermic. So what happens when hydrogen reacts with oxygen? It forms water simply, and a large amount of heat is evolved. The mixtures of hydrogen and oxygen, or simply we can say air, as in air we have a lot of oxygen. So it is explosive in nature and especially violent when the ratio of hydrogen to oxygen is approximately equal to 2:1. The name detonating gas is given to such explosive mixtures of hydrogen and oxygen. Experiment. Let us show that water is formed when hydrogen burns in air. We need a round bottom flask, blowpipe, beaker and hydrogen. Now put dry hydrogen is burned at the end of a jet of a blowpipe below an ice water cooled bulb of a round bottom flask. So this is basically hydrogen which is actually burning. This is basically ice and we are simply burning hydrogen in air. The product formed by burning of hydrogen in air condenses on the cooler surface at the round bottom flask and is collected in beaker placed below. So here what is going to happen actually, we are passing dry hydrogen at the end of a jet. This is a blowpipe. This is basically an ice water cooled bulb. So basically whatever the product will form, this will get cooled with this whenever it strikes the surface of this round bottom flask. So the product, whatever the product form, we know that hydrogen on reaction with oxygen will form water. So this product will get cools whenever it strikes the surface of round bottom flask. And then as we know that water is going to form, so water will move simply towards this beaker. The observation is going to be the condensed liquid is formed, which is confirmed by the fact that it turns anhydrous copper sulfate white to blue. Then reaction with nonmetals. Hydrogen combines with many nonmetals normally at high temperature in the presence of a catalyst. The first one with halogens. Hydrogen combines with halogens to form corresponding hydrogen halide. The reactivity of halogens in such reactions is in the order. The most reactive is fluorine, then chlorine, bromine, and then iodine. Hydrogen combines with fluorine explosively even in dark and at very low temperature. So hydrogen on reacting with fluorine gives us two molecules of hydrogen fluoride and the reaction is highly exothermic. With chlorine, the reaction is explosive in bright sunlight but proceeds smoothly at room temperature in diffused sunlight. So this is not at all much explosive in diffused sunlight. So basically this is hydrogen on reacting with chlorine will produce two molecules of hydrochloric acid. With bromine, the reaction occurs on heating. So hydrogen on reacting with bromine gas will produce two molecules of bromic acid or hydrogen bromide. With iodine, the reactions occurs on heating and the reaction is reversible. So hydrogen on reacting with iodine gas will produce two molecules of hydrogen iodide. Now reaction with nitrogen. Hydrogen combines with nitrogen gas at 450 to 500 degrees Celsius at 200 atm pressure is required and also a catalyst is required which is iron in order to form ammonia. Nitrogen on reacting with three molecules of hydrogen in presence of iron at very high temperature and pressure produces ammonia. This is the formation of ammonia. The complete process is actually called as the Haber's process and here the manufacturing of ammonia has been taken place. Now with sulfur, so when hydrogen is passed through boiling sulfur, the product obtained is hydrogen sulfide. Here is the reaction. H2 plus sulfur will give us H2 plus. Now reaction with metals. Hydrogen combines with many active metals or simply reactive metals at high temperature to form corresponding hydride. So molten sodium reacts with hydrogen to form sodium hydride. Similarly, potassium reacts with hydrogen to form potassium hydride. Calcium reacts with hydrogen to form calcium hydride. These hydrides are ionic compounds. Now reducing properties of hydrogen, reduction of metal oxide. The oxides of less electropositive metals. Less electropositive, you can say simply less reactive metals such as copper, iron, lead, etc. They are get reduced to the corresponding metals when heated in a current of hydrogen. This is copper oxide, which is in black in color. It reacts with hydrogen, and finally it hydrogen reduces the copper, and copper will be formed, which is red in color, and the water is as the side product. Then lead oxide on reacting with hydrogen also produces lead along with the water. Similar reaction happens with the iron oxide. So iron oxide on reacting with hydrogen produces iron plus water. Then similar reaction happens with the tungsten oxide. So it also forms tungsten along with the water. The oxide of strongly electropositive metals. Example, alkali metals, which is sodium, potassium, lithium, and alkaline earth metals, beryllium, magnesium. They are not reduced by the hydrogen. The reason is simple, they are more reactive in nature. Reaction with organic compounds. Hydrogen reacts with many organic compounds in presence of a catalyst to give hydrogenated products. Hydrogenation of unsaturated hydrocarbons. Unsaturated hydrocarbons simply add hydrogen in the presence of a catalyst to give saturated hydrocarbon. So unsaturated hydrocarbon is simply which has multiple bonds, either carbon double bond carbon or carbon triple bond carbon. Saturated is simply the hydrocarbon which contains only carbon single bond carbon. Here is an ethene on reacting with hydrogen in presence of nickel at 473 Kelvin will produce ethane. Ethine also on reacting with hydrogen in presence of platinum or palladium will produce ethane. These reactions are called as hydrogenation reaction. Then hydrogenation of vegetable oils. The vegetable oils such as soybean oil, cottonseed oil, groundnut oil, etc. They are called as polyunsaturated esters as they contain carbon double bond carbons. So when hydrogen is passed through these edible oils in the presence of finely divided nickel at 200 degrees Celsius, they undergo hardening and change into more palatable edible fats, which is called as vanaspati ghee. So basically, on hydrogenation, vegetable oils, which is in liquid, will be converted into vegetable ghee. As we know, it's sort of semi-solid in nature. We need nickel and 200 degrees Celsius temperature is required. I hope it is clear to you. Thank you.